However, unfortunately, x squared is not one-to-one. Therefore, x squared has no inverse function. However, you say, wow, but it's a shame. Okay, x squared have no inverse function. Well, you can, but you introduce restrictions. Sometimes if you express, for example, the function f of x equal x squared, if I ask you, this is one-to-one, the answer is no, it's not one-to-one. Therefore, it's no invertible. Invertible means okay, the inverse function do not exist. However, to save that problem, you put a semicolon and you introduce restrictions. Suppose x greater than or equal to 0. What means that? Well, okay, the domain at the beginning, we suppose if we have no that part, semicolon, something, I suppose assume okay, it's already a number, no? However, no. Is now semicolon x greater than or equal to 0. That means that I want only, for example, not necessarily always, but you have, or you need, or you want the positive part, the x greater than or equal to 0. So this is x squared again, the same formula, but I introduce restriction in the domain. Therefore, it's different function. It's the same formula, but it's different function. Because to define the function, we need to define the formula, but we need to define domain and range. So I make a restriction. This is frequently happening. And now my new function is one-to-one. Therefore, it's invertible. Do you understand this? So when you see, okay, I define a function, I put a formula, okay? I put a formula, but I put also a semicolon, y I express one set que I suppose hypothetically que es de domain, the new domain. Entonces, under that condition is one-to-one, entonces we have inverse function. Okay, the notation that we are using to represent the inverse function is like that. Inverse. Look like exponent -1, but actually it's not exponent. It's just symbolic way to indicate inverse function. Okay, when you see this f raised to the -1, it's not equal. No. Sorry, 1 over f. No, this is no. This is completely wrong. This is inverse function. You see that I put in word inversed. This is equivalent to say inversed of f. Okay? Entonces, let me try to understand what is inverse. It's super easy to understand the inverse because it's an intuitive idea. In mathematics, there are several inverse operations that we are doing every day, like addition, subtraction, multiplication, division, square root, and square power. Cubic root, cubic power. More complicated in general, right? Inverse is the opposite operation. Actually, the only thing we are doing is interchange domain and range. Suppose one elementary example. Suppose one function is f of x equal x plus 5. And the action of this function is addition 5. Okay, suppose you pick any number. Suppose add x equal 10. It's obvious the f evaluating 10 is 15. It's 10 plus 5. Okay, this is the direct function, no? in the regular direction. Suppose I want to find the inverse function. Well, using intuition, I don't know what is the formula, professor, to find the inverse function. I want to explain in a few minutes, but the intuition says que subtraction, no? Because it's the inverse function. So the inverse function associated with this guy is subtracting 5. Therefore, if you plug it in the inverse function, 15, suppose, is the answer for the direct. You have 15 minus 5, get 10. And we come back to the same 10 that we suppose at the beginning. Wow. So now the inverse function always does each other, direct and inverse function, and give me the same number. Entonces, how you represent this idea mathematically? Well, is you have the function, okay, f, and you form the composition is inverse, and the answer is identity function. In this example, you see the original function was the sum, addition, and this was subtraction. Entonces now when you are doing both together in compositions at one first and one second, you start for the one specific original number. Look at that, original number. Sorry, I forgot the argument. Parenthesis x, and the answer is x. Wow. It's like, I don't want to say that, but this is, you cancel out this and this. But actually, no, it's not proper to say it like that, because it's not division. You cancel out when it's division or subtraction. Well, actually subtraction, no? But in general, no. We working with the more complicated functions, and you find inverse. And opposite direction, you, for example, form the composition. Okay, remember I say that never the answer of this is the same, but in this case, yes, it's a particular example in which it's the same. So we're using this fact to verify, see the formula that we are finding the inverse is good or not. This is double check, right? And keep in mind, okay. One more thing before the example, theoretical. Remember, I prove that the function is one-to-one. Nice. It's a domain of f and this is the range of f. And the thing that we are doing is interchange x, interchange with the y. This is the most important idea, because you change the direction, no? Now, see, my function is in this direction. The inverse is in opposite direction. Opposite direction. Sorry. Let me erase that part. It's in opposite direction. The inverse. Now it's obvious that now this is the domain of the inverse now, and this is the range of the inverse now. So that is equal because it's the same set. Very important, this idea. Very important. So the domain of the original is equal to the range of the inverse, and the range of the original is equal to the domain for the inverse. Important idea. Important idea and important idea. Everything is clear? Okay, let's move on to the first example. In this example, we study everything. I give you the function. I want to prove if it's one-to-one or no. It's the first step. The second step is find the new expression for the inverse function. In the case scenario, in the case that exists. Because if you see no one-to-one, entonces stop. Professor, I cannot continue because that function is not one-to-one. Therefore, that function have no inverse. Okay, suppose the majority of the scenario, yes, is one-to-one. It's the first step. The second step, find the expression for inverse. So step number one is proof que es one-to-one, que F es one-to-one. Si the answer is yes, well, okay, we continue. Si the answer is no, stop, no more, because it's not invertible. What is the fantastic way to prove that? Oh, fantastic way is horizontal line test. You have the function, no? You have the equation for the function. You graphic, so it's very, very complicated using decimals, and you apply the horizontal line test. Si pass the test, so now the step 2 is find the expression or the equation of the inverse function. What's the key idea? Well, the key idea for doing that part is interchange X and Y. And the original equation, you permutation X and Y. And when you are doing this action, automatically, the expression you have in front of you is the inverse. But maybe it's the inverse. You get the inverse and implicit form. Remember, implicit means that Y is not isolated. So it's no good to see. And you need to apply some algebra in order to express it in explicit. Inverse and explicit. Remember, the word explicit indicates us that Y is isolated. In this case, no. In this case, suppose that you interchange is X equal F and Y. Wow. Look like weird. That you interchange, so the original is Y equal F of X. Right? You interchange. Chan. Now it's inverse. It's inverse, but no nice. It's implicit. Okay. You manipulate some algebra and you solve Y. And this is the goal. It's our goal. Inverse and explicit. Okay, number 3 step in the analysis, or with 5 step we have, is checking, double checking. What is the double checking? The double checking is that formula, is the formula decomposition in both directions. Is the same, unbelievable, but it's true. Not always happen, but in this particular case happen, and also it's identity function. Remember, identity function is a function that X and Y is the same. So Y equal X is a line, no? Identity function is a line can be set the first and the third quadrant, okay? Because it's see X is 1, Y is 1, 1,1, 2,2, 3,3, negative 1, negative 1, it's identity. So it's the same. It's line passing through the origin, so Y and Z is 0, and it's lower. Okay, super easy. Now double checking in both directions. Nice. When I'm sure that my expression is good, using double checking, so now the rest is cosmetic part. Number 4 is domain of the inverse function. Look at that. Domain of the inverse function. Okay, remember, it's easy in algebra. Investigate domain, and no easy, no trivial, no elementary. Investigate the range. The range is always complicated. Remember, in the problem, never we're talking about, well, never know. Sometimes, but in easy example, but in just complicated. So it's easy or relatively easy. Investigate the domain of the inversion. And you infer the range, the domain of the inversion. Okay, actually, we can do that because we have the expression, no? This expression is equal the range of the original function. Okay, maybe it's complicated. Investigate this. Now we open the door to one easy way, and the range of the inversion, the range here, the range of the inversion is equal the domain of the origin. Okay, keep in mind this idea. And finally, 5.12345, do the graph. This is super important now. Graph. Both. Okay, entonces es super easy because suppose que we have one function. Suppose hypothetically one function like that. This is the f, the origin, it's given. And you see, want to do the graph of the inversion. Well, okay, professor, entonces si I have equation, I do that. Okay, you can. But one fantastic way, one easy way is take advantage the fact that this is the identity function. The equation is y equals x. And remember one more time, okay, we are doing the interchange x and y. Therefore, suppose hypothetically, you see in several examples we are doing after this. Suppose that one point here. That point is the point, I don't know, 0.2. Now the inversion would be 2.0. Because actually the only thing we are doing is interchange x and y. Suppose hypothetically another point here, I don't know, suppose we guess 4.5. This guy. The other guy is 5.4. Approximately here. 5.4. And the curve look like that. It's important to understand okay, the graph, this is the graph, the blue is the graph of the inversion function. Okay, the graph of the inversion function is symmetric of the original with respect to the line y equal x que represent the identity function. Identity function. Oh, guys, I am exciting to see example. No more blah 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 theoretical thing, right? Let's move on to example. I bring several examples. We analyze by hand a little bit, and after we are using Desmond to see more clear. Okay, any questions so far? Do you follow me? Complicated? No, this chapter is easy. In my opinion. In my opinion, it's easy. But I need to, unfortunately, explain one theoretical thing, no? First of all. Okay. Example one say. Suppose one function is given f of x equal x cubed plus 3. Okay. So the test say, well, no, okay, I want to analyze everything. Analyze first, case 1-to-1 or no. Second, the equation. Third, the double checking, domain and range, and finally, the graph. Okay. Well, I have no idea. I am totally lost. However, I know, suppose by hand, okay, the graph of the x cubed is something like that. This is the graph of the x cubed. It's typical odd function. But the graph of the x cubed plus 3 is similar, because the only thing we are doing is a transformation 3 unit up. No, this is vertical shift 3 unit up. Therefore, the graph is similar. Suppose it's something like that. This is the graph x cubed plus 3. 3 unit up. Point by point is moving. 3. So the y is increasing plus 3. And the x, no. The x stays the same. You apply the horizontal line test, and the blue and the green curve, of course pass, crossing only one point. Therefore, it is 1 to 1. 1 to 1. Everyone follow me? For all real number, domain is, I suppose, it's all real number, because remember the agreement we studied in college algebra is the supposition of the one function is given to me. I suppose that the domain is a real number, except restriction. And the restriction maybe we have when you have denominator equal to 0 or a square root. An expression inside the square root is negative, so it's imaginary or complex. Not necessarily only square root. Any root can contain even index like 4 roots, 6 roots, and so on. But if yes, cubic root, fifth root, no, we have no restriction. Okay, so now the step number 1 is accomplished. It's done. The function is 1 to 1. Therefore, that function has inverse. Let's move on to the step 2, que is determine the inverse equation. Everyone follow me so far? Yes or no?
Yes.
Now, this is a crucial moment. This is the most important moment, at least for me. Remember, the key idea is interchange x for y. This is the key idea. Well, first of all, I would like to replace function notation for y. You know very well that y and f of x is the same thing, right? It's equivalent expression. It's equivalent. However, in your moment, we study that the function notation offered to me or to us several advantages to understand the function. But it's the same. You replace anytime you need. Now this is a crucial moment. You interchange. So now it's x equal y cubed plus 3. Do you see that? Wow, I like that. And that's it, professor. That's it. This is the inverse. Pero the inverse unfortunately, en implicit. And implicit, well, it's not clear. Entonces I need to express it in explicit, que es clear, right? Entonces it's super easy. In this case, you're subtracting 3. Apply cubic root both sides. Therefore, cubic root x minus 3 is equal y, only one y, because cubic root and cubic power undo each other. And this new y is the inverse function. Super clear inverse function in explicit form. Que es the form que I want. Okay? Entonces, conclusion, inverse expression is cubic root x minus 3. Yeah, and close the box because it's important. Si you analyze, makes sense or no? Makes sense que es cubic root of the original function. The operation it's doing is, first of all, according to the order of operation, you raise to the cubic power. So suppose you plug in an arbitrary number. You, according to the order of operation, you are doing exponent first, no? Cubic power and finally plus 3. And the inverse is doing the opposite, but in opposite operation, you're subtracting 3 and find the cubic root. I suppose you put each other together, it's a double checking part. The double checking part is number 3. Look. Double checking part is you put F composition F inverse, and magically happen that you get identity function because undoes each other. Undoes this and that. Let's see now. Wait. If you are doing opposite direction, professor, inverse first, and if we get exactly the same. Yes. I want to prove now. Look. Suppose I'm doing in that order. Remember, the composition is extremely important, the order. In this case, the first function is the inverse case. This. You plug it in, not here. No, you plug it in here, and the inverse function first. And the answer of that, you substitution here. In other words, is you copy that, the outermost function, que is cubic plus 3, and inside this you put cubic root x minus 3. Everyone follow me the thing I am doing? Okay, is this one? Let me use a different color. The green one is inverse. I substitution, and the orange function is the original. In this case, the supposition is the original in orange color is the outermost. Therefore, the green go completely inside the orange color, no? It's the original. Everyone follow me? Do you understand the thing I am doing or no? Well, it's easy because I know that cubic root and cubic power endorse each other. The answer is x minus 3 plus 3. Wow, and 3 plus 3 is cancelled out, and the answer is x get identity. Super good. Now let's do it in opposite direction to make sure. So students say, well, professor, it's enough. You're doing one direction. It's enough, but just in case I want to check it in both directions. Now I try to composite under the consideration that f is the first function. It's like a first function go inside. So the orange go inside the green. Let's see, it's in this direction. So I copy cubic root. In my mind, I consider x like a box minus 3. Inside the box, I copy the original x cubed plus 3. Okay, so now I can see cubic root x cubed plus 3 minus 3. Wow, this is cancelled. And stay cubic root of x to the cubic power is x again. Fantastic. Double checking work. I am sure now that the green expression represents perfectly the inverse function of this. Okay, number 4. Do you understand this or no? Yes or no? Yes or no? Complicated.
Using the explicit form, do you flip the implicit form and then square root it?
Say again, I don't understand very well.
When you try to find the explicit form, like, do you flip it again, like the x and y, and then you square root it?
No. In explicit form, the only thing I did was solve for y. So you try to manipulate algebraically, moving 3 to the left, apply cubic root both sides. My intention is to have y alone, isolated is cubic root x minus 3. I am not clear, so I understand very well your question, miss. What this is your question?
I understand now. Sorry, I got confused. Thank you.
No, it's okay. You are students. Okay, now number 4 is, well, determine domain and range of two range and two domain. Okay, domain of the original a range of the original, it's always complicated, a domain of the inverse, and range of the inverse. So for me, it's hard. Not in this case, but in the majority of the function determine domain, we have like a systematic way. So you detecting the restrictions and you remove of the real number, and that's it. But the range is complicated. Well, maybe graphically it's easier to see, but analytical no. So I propose you do it in different way. I propose you doing always domain and you infer the range. Okay, so now the domain of f is obvious que es a real number. It's obvious. The domain of the orange color is a real number, right? And domain of this. You say, well, professor, we have a root. What is a cubic root? And when the index is odd number, we have no problem. Let me explain why. You know that, right? Suppose that you have cubic root of -27. And -3 is real because -3 times -3 times -3 is -27. It's exactly the same the number that we have inside the radical, no? Otherwise, completely different situation happen when you have a square root -25, que is not real, you know. Actually, you know que 5i plus or minus 5i, no? And so you avoid this guy. So when you have index even, like a 2, like a 4, and so you take care, be careful. However, when the index is odd, like a 3, 5, 7, no problem. Accept any whole real number. Domain says all real number also. And you need to know that this domain is exactly the same that range. And this domain is exactly the same this range. Not always happen, but sometimes happen. Okay. Entonces now the graph, que es this is number 4, no? The graph, the 5 step is the graph. No, actually, it's easy, it's relatively easy. The graph of the original is the green curve I did before. And the graph, let's try to do by hand. And after, but because I want you to understand the power of this. And after, of course, we are doing using decimal notes. But let's do it by hand, for example. Let me use the rule. Okay. $90. Here. Well, I can use in positive and negative. Okay, X and Y. Okay, the original function was f of x equal x cubed plus 3, no? For example, at x equals 0, let's solve the y is 3, no? And the famous point is the point 0, 3. 1, 2, 3. I plot that point. 0, 3. And the inverse function is 3, 0. 1, 2, 3. One more. Suppose at x equal 1. No complicated value. 1,000, 1 million. Is 4, no? Because 1 cubed is 1 plus 3 is 4. Y is 4. And the famous point is the point 1, 4. 1, 4 is 1, 4 here, over there. This is the point 1, 4. And the inverse function is 4, 1. 4, 1 here, over there. 4, 1. Another nice, interesting value is -1. Wow, I like that. 0, 1, and -1 is almost typical. Entonces, -1 to the cubic power is -1. And -1 plus 2 plus 3, sorry, is 2. And the point is the point -1, 2. -1, 2 is here. Well, -1 here, -1, -1, 2, I suppose is here. This point is the point -1, 2. Therefore, my curve a little bit more accuracy look like that. You know, this is x cubed plus 3. Actually, it's the x cubed. Okay, I know the shape, okay, something like that. And this is 3 units up, point by point. See, this point is 0, 0. So this point in the transformation corresponds to 0, 3. So any point is moving 3 units up. What about the inverse? I forgot to continue. Well, is that point is 2, -1. So 2 here and -1. I suppose here. This point is the point 2, -1. And the graph look like something like that. Wow. If you remember, okay, this is the graph that corresponded with the cubic root x minus 3 equal y. This is equal y. If you remember, some students don't remember very well the graph of the cubic root. The student remember very well the graph of the square root, but the cubic root is something like that. Look, this is cubic root without transformation. In this case, -3. This is -3 is horizontal shift 3 units to the right because it's negative. And one more time, we have the famous identity function can be set. The first quadrant. And it's supposed to we have common point here. Third quadrant, first quadrant and second quadrant. And you see very well, approximately, I try to do my best. Now don't worry because I go to the small to illustrate perfectly this idea. How the inverse graph and the inverse and the original function is symmetric with respect to the line y equals x. Clear? Clear? Clear or no?
Yes.
Okay, entonces we analyze different examples. This is the example one. I know it's too long, sorry. But in different examples, we are doing, of course, we are doing a little bit fast. 1, 2, 3, 4, and 5 steps to analyze the inverse function. Okay, let's move on to Desmos to see the example number 1 in elegant way, no? In Desmos, switching Desmos. Let me know if you see Desmos now or not. Do you see or no? Yes or no? Answer me, please. What happened with the audio?
Yes, we see it.
Okay, now example 1, look. Example 1 is this. Wow. Look. I copied the original function, the famous 3 points, 0, 1, -1. And the corresponding y is 4, 3, and 2. And the inverse function, que is the green color, look. And you see clear, que share similar point, no? Pero you interchange x and y. No, this is more elegant idea. Any question? Super good? Super good or no? Or confused? Huh?
Yes.
Okay. Let's move on to another example. Okay, I want to show you something. Okay, erase everything. Do you see whiteboard?
Yes.
Yes or no? Yes. Okay. Example 2 now. Example 2. Suppose okay, this information is given, no? Determine no. The same is given this function. And we need to analyze everything. Number 1, remember, see the function is 1 to 1 or no. Number 2, find the expression for inverse. Number 3 is double checking. And number 4, domain and range. And number 5, do the sketch of that function. Do the graph. What do you think about that function? Is 1 to 1, yes or no? Come on, guys, participation. Opinions. I suppose, what is the best way to investigate? See, one function is 1 to 1 or no? What is the best way?
It's not because it's quadratic.
Exactly, it's not because it's quadratic. So the reason is immediately I have the expression, I do the graph, I saw it's something like that, and do not pass the horizontal like this. The answer is no, that function is not 1 to 1. Therefore, this is not invertible, que es sinónimo to say que the inverse function do not exist. And end the story. However, I don't want to take advantage to put semicolon x greater than or equal to 0. Now, I repeat again the question. This new function, because actually it's the same formula, but I make restrictions in the domain. Therefore, this function is a new one, no all real number. So you don't don't write any restriction. The supposition you assume the domain is all real number, but in this case, no. I assume that the domain is only the positive number, including 0. Or another example, the negative. It doesn't matter. I need to select one. I select the positive because I like the positive, no? Okay, so now under this new condition is 1 to 1 or no? Answer me. What do you think? Answer me. Huh?
Yes.
Because this is a half of parabola. Okay, it's only the positive, the other part is missing. No, 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 no. Only half of parabola que corresponde with the positive x value. And when you apply the famous vertical no horizontal line test pass, it's 1-to-1. Okay, so this is the idea. The idea is you need to be aware that sometimes the function is given and introduce restriction in order to convert to 1-1. So the frequently question for the student is, Professor, what the hell is that part? What the hell is that part? No, that part is important. That part is the restrictions. Okay. In other words, you say, bueno, entonces es domain or no? Of course it's domain. O sea, we can write in different way. This is the typical style to write the problem in this example. However, you specification domain of this function que I want to declare is bracket 0, infinity. It's the same, right? That is the same of this. Anyway, either way. Okay. Now ready to, well, yes, so in this case, it is 1-to-1. Nice. Therefore, f of x has inverse. Well, okay. I understand. But what is the inverse? This is step 1. Step 2 is find the inverse. Remember the idea, interchange x and y. And the original. You replace y, f of x for y. Don't forget that. Entonces es x is equal to y squared. That's it. This is inverse, of course, in implicit. Because y is not isolated. And never is good. Bueno, and square root x is equal to y. This is no surprise. Es obvio. Es obvio que the inverse function for the square power is the square root. Ese es elementary. No surprise. Okay, now, what do you think? I put opinion. Plus and minus or only plus? Huh? Nobody have opinion? I suppose que no. Why no? Okay, the graph of this is 1/2 of parabola. The graph of this, so you put in decimal, for example, is like that. It's a parabola, but full parabola, right? However, it's obvious que no. The negative part doesn't work. And then you put positive only, entonces es something like that. Okay, it's the graph. You take positive part because you need to be consequent with the idea that it's only valid for the positive. Okay? Okay, now double checking. Double checking is, suppose f composition f inverse is equal f inverse composition f is equal identity. Let's do it in both directions. Inverse is this. This is inverse. Okay. And this is the original. This is the original. Okay. In this scenario, in the first one, you put the orange color inside the green. This is the green. Wow. This is the green. And this is the orange. Okay. The first function is the orange inside the green. Okay, let's do it. It's easy. Is like a square root of x squared. This expression is substitution, so you replace mentally x in the green for square root x. Oh, I know they undo each other, it's x. And the second scenario is, again, is different. This is the orange, this is the green. You put the green inside the orange. So you replace that x for x squared. So it says square root x squared. Something like that. Again, is x. Double check. Undo each other, the actions, the operations, and you get the identity. It's the same number at the beginning, you suppose. Domain and range. Domain of the original. Range of the original. Domain of the inverse. And range of the inverse. Okay, domain of the original is given at the beginning. Is this? If you want, normally in the test, this is expressed in interval notation, no? So it is bracket 0, infinity. And this domain is equal the range of the inverse. I don't need to analyze anymore. I just copy and paste. However, the range is more. No, in this case, no complicated. So obvious is pause the number. Look in this graph, you see clear. You see clear. Okay, the domain, the range, sorry, is that part. So this is equal to this. Domain inversion. Well, okay. Domain of the inversion. Be careful. Here we have restriction, and the restriction by coincidence is the same. You take the expression inside the root, you declare it must be non-negative, and this is coincident with this. And this is again bracket 0, infinity, and this is the range of this. Okay, guys, no, in this example, number 1 and number 2, they are coincidence, everything is the same, but no. You see another example, no, not necessarily the same. And number 5, well, number 5, I appreciate it so much doing. No in the paper, no, hello. We move into Desmos. To see more clear. Okay, there you go. I suppose you see Desmos now, yes or no?
Yes.
Yes, that was example 1. The example 2 now is, boom. Look at that. Okay, and the blue color, we have the famous parabola, or no parabola, half of parabola, no? Because we need the one-to-one, no? In orange column, I have the famous square root function that everyone know very well. And the important point 0, 0, 1, 1, 2,4, because in the blue is the power, so it's a quadratic function, square. 2 squared 4, and the square root 4 is 2, no? We can plot another point. Yeah, we can plot, for example, 9.3 or, let me see. Let me separate by comma. Separate by comma. 9, 3. Boom, nice. Too far, but it's nice. And the corresponding value in the Richard function is 3,9, no? Because 3 could be 3 squares of 9. Okay, in the what color? In this color. In this color, get blue. 3,9. You see completely the symmetry. In this case, they are coincidence because 0, 0,0 share both curves and 1,1 share because 0 square is 0. Square root 0 is 0. 1 square is 1. And square root 1 is 1. But the rest no. And the negative do not participate in the game. The negative value, totally out of the domain. Any question? Any question? Okay, I want to put one a little bit more complicated example. A little bit, not too much. You see whiteboard now?
Yes.
This is example 3. Okay, suppose que it's the last. Because you get idea about that part. And that part is the introduction to the new function that we are studying. We are studying a new function that is exponential function and logarithmic function. And by the way, exponential and logarithmic are inverse function. Each other, right? That is the reason that we study inverse function now. Okay, suppose que it's given that function in the example 3. F of x equal 1 over 1 plus x. And we're doing exactly the same. The 5 step. 1, 2, 3, 4, 5. Well. The function, bueno, I have no idea. However, in the library of the function that the professor sent me by email, I saw the famous reciprocal function that look like that, the graph 1 over x. This 1 over x has one vertical asymptote here at 0 and one horizontal asymptote in y equals 0. However, this is different because it's plus 1. So this interpretation like a horizontal, because actually, so what is the difference between this and this? This is f evaluating x plus 1. No? So we are doing something like that. We are doing the horizontal shift, but 1 unit to the left. To the left because it's positive, no? So approximately, the transformation helped me a little bit to understand the graphic, no? The graph of this, the given, is similar to this, except that the horizontal asymptote stay the same because the motion is horizontal. Entonces, horizontal asymptote is horizontal. And when you move horizontally, doesn't change. However, the vertical, no. The vertical change because normally it's located at x equals 0. Now would be at x equals -1. Okay, by the way, is the value to be undefined. X equal -1 plugging in here, -1 plus 1 is 0 in the denominator. Okay, now my graph look like that. Okay, this is the graph of the 1 over 1 plus x or 1 over x plus 1. Okay, by the way, it's the same. Okay, my first question is, when you apply horizontal line test, pass the test or fail? Of the new one, of the given, of the original. Pass or fail?
Pass.
Pass, very well. Okay, si es one-to-one, entonces es invertible. Y my goal is find the inverse function. Okay? Step number 1, determine si es one-to-one. The super fantastic way is doing the graph. You have, in Euclid algebra, you have equation of the typical function that we're using in the real life. Reciprocal function, wow. How do you know? We use 1 over something, no? Reciprocal. But you have a little transformation, okay, so in this case, horizontal shift 1 unit to the left because of plus. Okay, so let's move to the second step, because the most important is interchange X and Y. Interchange X and Y. Okay, entonces remember, f of x, automatically I replace for y. This is my original. I recopy again, recopy. Now I apply that idea on this. It's x equal 1 over 1 plus y, correct? Okay, I got it. This is the inversion implicit, but implicit is no good. Well, it's good, but no elegant, no, to see. Therefore, you must do something algebra in order to isolate this. I propose cross multiply. Cross multiply. Okay, x times this is equal to 1, no? Because I suppose in the denominator here we have nothing. It's because the number here is 1. 1 times 1 is 1, no? Now distributed. X times 1 is x, xy equal 1. Therefore, my goal is y, so xy is equal 1 minus x. Finally, divided by x, both sides. Okay, the new y is 1 minus x divided by x. Okay, by the way, this new y is the inverse. This is the answer. Okay, entonces, professor, I have no idea. This is the function that we study in college algebra. This new one, or no? I suppose que yes. Because in order to see more clear, you have 1 minus x divided by x. So you split this common denominator, you have 1 over x minus 1. Wow. Okay, does it look like similar, very, very similar to this one? Look, it's 1 over x, but you can see now a vertical shift 1 unit down. Vertical shift 1 unit down. Therefore, I suppose after in decimal, probably you see both together. But I want to anticipate something. No, look. we have here obviously vertical asymptote at x equals 0. At x equals 0. Okay, vertical asymptote at x equals 0. X equals 0, vertical asymptote. However, we have horizontal asymptote at y equal -1, no? Remember the degree analysis. The degree of the polynomial at the top is 1, linear degree is 1 also. Yes, we have horizontal at the division of leading coefficients, okay? -1 divided by +1 is -1. This is one point of view. This is one point of view. Another point of view is, suppose, so we have horizontal at y equal -1. Another point of view is, okay, I don't remember anything about vertical asymptote, horizontal asymptote, okay, but I remember calling algebra, and I remember that function is this function subtracting 1, and one possibility of the interpretation is vertical shift 1 unit down because it's negative. Does the curve look like that? Ooh. Don't forget that we have here vertical asymptote. Entonces, well, the most important moment that I want to emphasize is, okay, it's typical only for this example. And the original, is this. We have vertical asymptote at x equal -1 and horizontal asymptote at y equals 0. Nice. And inverse, and the hypothetic inverse that we found, this is inverse. We have a vertical asymptote at x equals 0 and the horizontal asymptote at y equals -1. Do you see how the value of the vertical asymptote and horizontal asymptote is also interchanging? So vertical asymptote is -1 now, and the inverse, the horizontal is the same value, of course, y, no? So how the action of the interchange x and y interchange the asymptote positions. And this is important. Can you understand? Because this always happen in more complicated expression. Okay. Do you see that or no? And that's
Yes,
I promise. Yes. And that's I promise you see more clear. I try to do my best, and the roughly sketch, but no good. Now double checking. Double checking is, wow. Well, double checking is F composition F inverse, or either way, F inverse composition F. And remember, we have different color. We have green color and orange color. I don't know if you're using the same color in any example, but I put two different colors, no? To denote orange is the original, is F. And green is F inverse. Suppose I am doing in this way. I copy that. F composition F inverse. That means que the innermost function is F inverse. So the green go directly to the orange. This is easy. You copy the orange, get the outermost 1 over 1 plus box. You put a box in the place of x, and you replace x for this expression. It's 1 minus x divided by x. Do you understand what I'm doing? Do you understand the thing I am doing? Hey, are you there?
Yes.
Okay, good. Now the rest is algebra. It's doing. Well, I rewrite again with our box. 1 over 1 plus 1 minus x divided by x. I propose you, for example, 5 find the least common denominator is x. We have x plus 1 minus x. Wow, look like what happened. This cancel out and stay only 1 over x. And this is reciprocal. And what is the reciprocal 1 over x? Is x. Identity function. Super good. Now let's do it in another way, another direction. Another direction is F inverse composition F. Basically now, the orange color replace for X and the green color. So my green color is 1 minus box divided by box. And who is inside the box? 1 over 1 plus x, que is the orange color. Wait, let me make it zoom. 1 over 1 plus x. Okay, let's try algebra. Pero no too complicated algebra, it's intermediate algebra. LCD is 1 plus x. And we have 1 plus x minus 1. Divided by 1 over 1 plus x. This is cancel, positive 1 and negative 1. The answer is x over 1 plus x divided by 1 over 1 plus x. So you copy the first and flip it the second. So because this is cancel and the answer is x. Double checking is okay. I proved somehow that this green function is exactly the inverse function of the orange. On those each other gonna put together in composition. Regardless the order. Domain. Let's focus on the domain. Domain of wait a second. Domain of F. Range of, it doesn't matter the order that you prefer. Maybe the order I use is not good for you. Domain of inverse and range of the inverse. I like to put the domain first because it's easy for me to understand domain, and you infer directly the range. Domain of the region is all real number except -1. Do you understand this? Okay, you write if you want in interval notation or you want in the set builder notation. Okay, my opinion is either x such that x no -1. This is domain of the F. The only illegal value violation of the algebra is -1 because -1 plus 1 is 0, division by 0 is undefined. I suppose you understand very well this because we practice a lot of problems of this. And what is the domain of the inverse? Oh, it's easy also because I take the expression, I take the denominator, I don't care the numerator, no. To say it's x such that x no 0. The illegal value is 0, division by 0 here is undefined. And the same idea you copy and paste here. You see in this example it's not the same, it's different. Is range of the inverse function is equal the same set, the same kind of set, but in this case no x is y such that y no -1. And likewise here is y such that y no 0. That is a reason que en the inverse function the domain, look, is not 0. Look, that is the reason that we have vertical asymptote in 0 because it's totally out. Remember, there are two possibilities to be undefined: in vertical asymptote or in holes. In this case, we have no hole in vertical asymptote. And in the range the only value that never the graph touch a -1 because it's the horizontal asymptote, a -1. So the curve approach it, but never touch -1. Super good, super good, super good. I like that. Now, let's move into Desktop to see the graph, because in this case, it's a little bit more complicated doing by hand, no? But I prepared Desktop to understand more clear. Okay, let me know if you see Desktop or no. Do you see? Do you see now? Desktop?
Yes.
Yes. Okay, super. Now this is example 2, now example 3. Example 3 is, wow, look at that. It's confusing. What the hell? Look. Well, let me try to analyze step by step. Okay. The original is the red one. Okay, I want to remove purple color and this. Well, the point, this information is only the information for the inverse. Okay, this is my, okay, and why not the identity function? Okay, this is the original. You see clear like a water, okay, it's a rational function. This rational function has a, well, has a vertical asymptote at -1. Let me flash in that. And horizontal in 0. And the typical point, well, no, not typical, it's not important. Okay, this is now the famous identity function, and the graph of the inverse function is this. The purple color. This is the inverse function. You see that somehow they are symmetric with the line y equals x. Okay, that part is similar to that part, and that part is similar, symmetric. Like this behave like a mirror, no? And the most important moment now, the horizontal asymptote of the inverse, que is the purple color, is a -1. Look. And the vertical is at 0. Okay, entonces es importante que you see, notice the permutation in the value, no? Okay, in the original, the vertical is a -1. And the inverse, the horizontal is a -1. Okay. However, in the original, the horizontal asymptote is at x equals 0. And the inverse function, the vertical is at x equals 0 also. So it's a permutation. That makes sense because you interchange x and y. And point by point happen exactly the same. Look, this is the point associated with the original, 0,1, and one more, 1,5. Well, this is the, yeah, this is the original, 1,5, 1/2. And the inverse would be, look, this point is 1,0. Do you see how transform is 0,1? Let me make a zoom. 0,1 and 1,0 in the inverse. And the other is 1/2, 1/2,1. Okay, not bad. I understand very well now inverse function. Any question, guys?
It's clear.
It's clear. I like to hear that. Okay, entonces now I propose you in the time that we have, it's not too much. Introduce the new member of the family of the function, que It's called exponential function. Super important, guys, when you take calculus. No. Hello. Like note. Exponentials the name. Next name is exponential. I put in plural because it's a family, no? Of the function. Okay. Their name is exponential. Okay. All right. Let me start for definition. Definition. Definition of the exponential function is it's a function such that you define like a to the x. And who is a, professor? A is the base, the name, the base, it's a number. It's well, let's call real number. No. We have restriction with the base. I want to clarify now. But the name is the base, and the base
Professor,
in general.
Professor, show Desmond.
Sorry, because I am focused on the mathematics. I forgot the most important moment. Is who I believe did I now?
Yes.
Now?
Yes.
Okay. So I say the definition is a to the x. Okay, it's important. It's important. Can you understand very well the difference? Look, we are familiar, for example, x to the second power. It's a parabola, no? Or x to the cubic power. It's a monomial, but this is form a polynomial. But in this case, no, it's 2 to the x. So the argument, the variable, is located now in the exponent. And the base is a constant, but it's a number. And a number, be careful, is in general, it's a real. It's a is always positive number, positive real number. And two illegal value, or no illegal, trivial, it's not important, is a non-zero and a no one. It's trivial, it's stupid, because 0 to the any power is 0, no? And 1 to the any power is 1. And important, a negative number to the x is no exponential. No exponential. No. This is nothing. It's illegal to plug it in here when the base is negative. It's real. This is an important statement. Always positive. Real. No. Maybe irrational. Why not? Radical 2 to the x? Yes. It's perfectly legal. It's possible. A real number, but positive. No 0, no 1. However, we have to kind. I separate two groups of the exponential. Exponential, for example, you see one professor, okay, let me see. Let me try to understand because it's confusing. This is my rule, 0 degree, because I want to analyze the problem in one dimension. Zero. Oh, this line represents a real number. Here I want to analyze the interval when it's valid the exponential. Definitely no negative. This is 0 in the middle. No here. A no here. Never. We are talking about A base. In this case, yes. However, I want to emphasize that no is 0. No. we have a hole in 0, and we have a hole, another hole in 1. Hole. No and no, trivial. However, we have two intervals. This interval and this interval. Forever, to infinity. Okay? It's when the A is in between 0 and 1. This is one special kind of exponential. And this is when the A is greater than 1. When you have that situation, que is the most popular, when the A is greater than 1, is because we have increasing exponential function. Okay? However, if you have A in between 0 and 1, we have decreasing exponential. Okay, function. Normally, when it's increasing, in the colloquial language, you got growth, exponential growth, because it's increasing, no? And another language we're using when we talk about decreasing is decay. A decay exponential means que the function decreasing. It's obvious the base is a number less than 1. Like a typical example, okay, I want to discuss it, not today. Suppose this, okay, well, suppose this, 2 to the x. The base is 2. And you classify here is increasing, it's growth exponential. Suppose now f of x is equal 1/2 raised to the x power. Oh, the base is 1/2. And when the base is less than 1, it's in between here 1/2 is decay exponential. Okay, you accept this idea because I promise that next lecture I want to explain in detail why is growth and why is decay, right? Okay, look, another example. Suppose 2 examples, and you let me know. Suppose 4/5 raised to the x power. And another function, g of x, 5/4 raised to the x power. Classification, is exponential yes or no? And is growth exponential or decay exponential? Number 1 and number 2. Opinion. Both functions are exponential, yes or no? So we have 2 questions here.
First one
Question
is
number 1.
the second is growth.
Okay, first one is what?
Decay.
Decay. And the second, growth.
Yes.
You say?
Yes.
Perfect. And both are exponential, right?
Yes.
No problem.
Yes.
No problem, because the base is an important number now, and the function that we are studying now, the base is important, is non-negative. Yes, negative. Suppose que I put in the stupid example -4/5. The question is, this is exponential or no? No, because it's totally illegal value of the base. Okay? Now, the challenge for today, the last challenge for today is prove somehow how fast, so what are the differences between the very well-known power function and the exponential function. Doesn't matter the base, 2 to the x. Okay, the challenge is determine si that function increasing faster than this or no. I'm not sure. So the exponential, bueno, maybe you say, bueno, professor, you compare two exponential, 2 to the x and 3 to the x, es obvio que 3 to the x increasing faster than this, no? It's increasing faster than this. This is clear. This is obvious, right? However, compare exponential and any power function, no? It doesn't matter if it's x to the second, or x to the third, or x to the fourth, or x to the 2,000, or 2 million, okay? To illustrate this idea, look, classical example, que es very contemporaneous with the situation of we are living in the world, es the pandemia, no? Maybe you hear que the pandemia propagate exponentially, right? That means que es too fast or is slow? Nobody say que the pandemic propagate quadratic or cubic or 4 power. They propagate exponentially. Exponentially is, look, suppose que es 2 to the x, no? You have one guy que have coronavirus, no? And contaminate 2. So this is the beginning of the pandemic, no? Suppose. Or contaminate 3. Depende the base que you want to model. Si es 2, suppose 2 to simplify. Si es 3, entonces we contaminate 3 guys and so on. And it's contaminate 2 more. Suppose que the base is 2, stay 2, and so on. So it's something like that. Okay, look, this is the beginning, que I suppose 0, situation 0, and 2 to the 0 is 1. One guy is sick. Next stage is 1. 2 to the 1 is 2 guys, and so on. This is the second. 2 to the second power is 4, and so on. Do you understand very well the exponential? Do you understand very well? So what do you think? Increasing faster than the polynomial, quadratic, or cubic, or 4, or I don't know? Suppose one problem for you. Think about that problem, I give you extra point for the student to get the answer, right? Suppose we have a box. Okay, guys, you have time to think about this. Anytime you email me with the answer of this. Don't share your answer with another student, no? This is not funny, no? Suppose you have a box, and inside the box, I put one coronavirus here. This coronavirus. And this is the situation at 0. T equals 0. T equals 0. And the velocity of propagation of the coronavirus, 0 minute. 1 minute is, suppose the same box, but I suppose que the exponential is 2, the base is 2, entonces you have 2 coronavirus, no? Do you understand this or no? But the number of the virus is 2. Of course, it's not true. The virus propagate too fast, but bueno, this is mathematical example, no? So this is 1 coronavirus, this is 2 coronavirus. What do you think about 2 minutes? How many coronavirus we have in the box? In 2 minutes? t equal 2 and t equal 3.
4.
4, very well. 1, 2, 3, 4. And what about t equal 3? How many coronavirus we have?
8.
Absolutely. 1, 2, 3, 4, 5, 6, 7, 8. And what about t equal 4? We have inside the box. How many?
16.
16. Very well. So you understand how behave the exponential. It's duplicate the same. So if you want to investigate, next is 2 times the previous. Yes or no? Well, in this case 2 because I assume that the base is 2. If the base is 2, so now you want to investigate x in m is equal to 2 times x in n minus 1. And this is the number of the stage 3, 4, 5, and so on. No? So basically, the number of the virus and the state number 5 is equal to 2 times the state of the value and the number 4, no? n minus 1. And number 4, we have 8, no? 8 here. This is 16. Can duplicate this. This is 4, and so on. This is 2. This is 1. Do you understand the propagation or no? Suppose, this is the complicated part. Okay, this process continues. Bam, 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 bam. And I discover okay, in 1 hour, t equal 1 hour. Look, this is to confuse you because we are talking about 2 minutes, 3 minutes, 4 minutes, and to side chain now to the 1 hour. Wow, confusing. And the moment we have completed full of coronavirus inside the box. So we have 100% virus and 0% of air. No air, no more. And I suppose that 1 minute after 1 hour, the box explode. Ah! Or no, because I suppose que science fiction box and maybe duplicate in 2 boxes and continue the process, no? I suppose. It's mathematics. If I want to investigate at 1 minute, this is the question, guy. At 1 minute, here, I suppose que it's intermediate here, we have that situation. We have a lot of coronavirus, but not too much. We have 50% virus and 50% of the air. This is the question. So the question is at what minute happen that situation? Do you understand the question? Do you understand the problem or it's confusing? Don't say nothing. You only copy. I give you 5 extra points for the written test again. The student can answer correctly that question. Of course, no, because I believe, no. You prove mathematically. Suppose que es at 25 minutes. You prove mathematically at 25 minutes. Not necessarily doing now, because this is just the beginning, no? And you start learning now a exponential function. So you don't know very well exponential function, no? But in the middle of the semester no, in this chapter, maybe you are more clear to understand this. Got it? You understand the idea? 5 extra points, yes. I promise. Yes. Any student can answer that question. And fundamentally, proof mathematically. No, because I am wizard. Entonces I believe no. Prove me mathematically, okay? Okay, guys, that's too much for today. We continue next time exponential function, and maybe we study another functions. It's super important in this part, in this chapter. Okay, stop sharing. Okay. Okay, guys. Bye-bye. Have a nice day. Okay.